All right, welcome to part 3 of Listen for week 5. This part is about Charles' law. Charles' law discusses the relationship between volume and temperature as we are keeping pressure constant. So two variables, volume and temperature, have been related by Charles' law by keeping the third variable, pressure, constant. Charles' law states that the volume of a given mass of a gas is directly proportional to the absolute temperature of a gas at constant pressure, or the ratio of volume and temperature of a given mass of a gas remains constant at constant pressure. So this time we are going to deal with the ratio of volume and temperature. Mathematically, V is directly proportional to T. And as we remove this proportionality constant, we come to place we have to remove proportionality sign. We will place proportionality constant K, and we'll shift this T to the left side, and the relationship becomes V over T is equals to K, where K is proportionality constant. Hence the relationship becomes V1 over T1 is equals to V2 over T2 is equals to constant. All right, let's move to experimental illustration of Charles' law. All right, here you are shown with a container with the given volume of a gas. As we increased heating by Bunsen burner, see the temperature reaches to 600 Kelvin and the pressure and the volume increases to 50 liters. Previously it was 25 liters and the pressure remains constant at 1 atm. This shows a direct relationship between volume and temperature, where V is equals to KT. K is proportionality constant, and this is by Charles' law. As we have removed the heating and the temperature decreases, see the volume also decreases and it reaches to 25 liters at 300 Kelvin from where previously we started. This is how volume is directly related with temperature as shown in front of you. All right, let's have another illustration of Charles' law in front of you. Charles' law discusses the relationship of temperature and volume. If temperature increases, volume also increases. There exists a direct relationship. Suppose a balloon in front of you is placed at 300 Kelvin and its volume is 2 liters, and if we increase or keep on heating it and raises the temperature to 600 Kelvin, so what do you think? What will happen to this balloon of gases? Of course, the balloon of gases, the volume will become double as the gases expand on heating. So this is a sort of direct relationship between volume and temperature. As the temperature of a gas increases, the volume of a gas increases. This is a direct relationship between temperature and volume, and if temperature decreases, volume of a gas decreases. See, if we are going to draw a graph between volume and temperature, volume along x-axis, temperature, as the relationship is direct, a linear relationship exists between volume and temperature. So there is going to be a straight line between volume and temperature for a given mass of gas if pressure is remained constant. The relationship we conclude is V1 over T1 is equals to V2 over T2. This is the relationship of Charles' law that we are going to use in coming numericals. All right, let's continue with problem solving strategy for Charles' law. Once again, you can come across two types of problems associated with Charles' law relationship. You may be asked to find out if Charles' law is applicable or not on a given set of data provided to you, or you may be asked to find out the unknown variable for the given set of data provided. The solution strategy involves the use of relationship of V1 over T1 is equals to V2 T2. Important thing you need to consider in solving while solving Charles law related numericals is that you need to convert temperature first to Kelvin. Whatever scale is given to you for giving for the data, you need to convert the temperature units to Kelvin first, and the relationship used for conversions are Kelvin is equals to degree C plus 273. So you are going to use this relationship for first converting your temperature values, and then you are going to use them, and finally you are going to use this relationship to solve the numericals related to Charles' law. Here is an example solved for you people. Table 5.5, you can refer to your books. For example, 5.2. Table 5.5 shows the data of a volume of a gas and its temperature for the given mass of a gas at 900 mmHg. So the whole values, the whole readings have been taken at a fixed pressure, that is 900 mmHg. So it means pressure is constant. So you are going to follow Charles' law. See the readings now. Temperature for very first set, the temperature is degree Celsius, volume 107.9 cm cube is given. The third thing you need to do is first convert your temperature to Kelvin. You are going to add 0 plus 273. So you are going to convert first your 273 will be your answer over here. For temperature, and then you are going to use this temperature and the volume given, this volume and this temperature, to calculate your V over T for here. Please do it side by side. Similarly, for the second set, you are going to calculate your answers, please. 5 temperature is given in degree Celsius, volume is given 109.7, and you are going to calculate first, you are going to convert your temperature to Kelvins. 5 plus 273, so you are going to first calculate your answer for Kelvin over here, and then you will calculate your V over T. I have done 2 for you people just to help you out. Third and fifth has been done by me. Look at this. 10 degrees Celsius has been converted to 283 Kelvins by adding 273 in it, and then I have divided 117.7 to 283 V over 2. So my V over 2 calculated is 0.397. I hope so the readings you people are calculating for 1 and 2 are also coming the same. Then comes the fourth set of data. Please do it quickly, do it side by side, so that you can just have a hands-on practice. Similarly, the last one has been done for you. This is 20 degrees Celsius converted to Kelvin, 293, and volume is 115.5 divided, and finally we come to 0.397 answer. So for the two data sets are obeying the Charles law, and I am equally confident that the other 3 you people are going to calculate are also obeying. So the whole experimental setup is actually obeying the Charles law. This is how you're going to deal with the numericals of Charles law. You're going to make sure you have converted temperature to Kelvin, and then you have calculated the readings. If the readings are constant and the answers are constant V over T, it means the whole set is obeying Charles law. With this, our laws are ended up. Let's have a quick recap for lesson for week 5. We have discussed general characteristics of gaseous state like diffusion and diffusion, Diffusion is movement of molecules from high concentration to lower by random or spontaneous movement. Effusion is the escape of molecules one by one. Compressibility is when you can apply pressure and the volume can be decreased. Mobility, the movement, the random movement of the molecules from one place to another. Density, we have talked about. The gases are usually less dense, but we can increase the density by increasing pressure on them and by lowering their kinetic energies by cooling them. Pressure, force per unit area, we have also discussed that how pressure is related with volume, inversely related as by gas law, Boyle's law, and how this is important to relate with the collisions of the wall with the walls of the container as well. If pressure is high, the more collisions are there, and if pressure is low, less collisions are there. Then we discussed or we concluded the effects of temperature and pressure on gases based upon KMT, kinetic molecular theory. We discussed in detail that how the increase in pressure results in increasing the kinetic energies, and as a result the volume is decreased. If pressure is increased, the volume is decreased, and if volume is increased, the pressure is decreased. Inversely related, similarly, how the volume is related with temperature, and kinetic energies are affected directly with increasing the temperature. The kinetic energies are increasing, and if kinetic energies are increasing, more number of collisions are there. So the whole effect is discussed under kinetic molecular theory. We also stated Boyle's law, derived its mathematical relationship and applied it on a given set of experimental data, and hopefully now you people are able to solve the numericals related to Boyle's law. Similarly, we have stated Charles' law, direct relationship between volume and temperature, and we have derived its mathematical relationship, and now you people are able to follow the application of the relationship on the numerical data given to you. All right, what's next now? You are now directed to reach to the resource folder to extend your learning outcomes. Few links are there. You can use those links to extend your learning outcomes. Then you can click on the assignment section to find out the written tasks associated with each subtopic. Do a lot of written practice for solving the problems. And that's all for now. Good luck to you people. Stay safe and stay healthy. Thank you.